This lesson will be about inference for regression. So if you remember linear regression, we always had a linear regression in the form y equals mx plus b. We always had an equation that way. Now, the one that's listed on the AP formula sheet, that's the one I'll give you. It's listed as y hat equals b0 plus b1 times x. So just notice that it's out of the y equals mx plus b order. B sub 0 is our y-intercept, and b sub 1 is our slope. So we did this in the past. We're actually going to start something a little bit new with it. Remember, when I say inference, that means that we're going to be doing hypothesis tests, and we're going to be doing intervals. And this is going to be done when you have two quantitative variables. And they're going to be paired quantitative variables, so you will have them as a set of points. So the one thing I want you to know for this first part is that the B1, the slope, actually, it's not the parameter. What's going to happen is you're going to collect a set of data. You're going to try to make an equation to fit that data. The B sub 1 is a sample statistic. So the actual slope, we're going to denote using beta 1. And if that beta sub 1 is 0, that means that there is no association between the two variables. Okay, so what we're going to be doing is we are going to be creating a performing a linear regression t-test, and that's going to tell us if there's an association. So we are going to have two hypotheses. The first hypothesis is that there is no association, beta sub 1 equals 0. And it's important that you somehow either you need to define the parameter beta sub 1, or you need to just write out the hypothesis in words. Either of those is acceptable. So I'm going to show you how to write it out in words. If you decide to define the parameter, you would do something along the lines of beta sub 1 is the true slope of the line, of the regression line, for whatever your two variables are. And so make sure that you talk about it in the context of the problem. In this case, we would have HA is going to be that beta sub 0 or beta sub 1 is not equal to 0. There are occasions where you do greater than, but almost always it's going to be just not equal to. And then for this one, you would say there is an association. And my recommendation is that you do, rather than defining the parameter, that it's easier to just write the hypotheses in both words and symbols. Okay, so let's talk about conditions. So your first condition is always going to be the random sample condition. That's going to be pretty standard. Now, unfortunately, for this one, pretty much every other condition is new. And so this one doesn't come up very often. If you forget the conditions, I would rather you actually focus more on the other tests than on this one, but I do think it would be good if you try to remember these. So the first condition, other than the random sample, is the straight NF condition. In other words, there are no bends in either the scatter plot or the residuals. The second condition is that there is no change in spread on either the plot or the residuals. And the last one is that the residuals are nearly normal. Okay. The other thing that's more important than this is the degrees of freedom. The degrees of freedom in this case is going to be n minus 2. And n is going to be the number of data points. And each data point includes two numbers, like an x and a y. I'm also going to give you the confidence interval formula. It's going to be B1. This is going to be, by the way, your sample slope plus or minus t star times standard error. And the margin of error here is going to be calculated in the way that you calculated it for any t-test. So let's go ahead and do an example. Okay, before we actually do this example, I just want to kind of go through just a little bit of stuff here. I want you to note that, first of all, that you see, you're going to see two lists of numbers here. Actually, these ones here, the top ones and the bottom ones, they are in the same column. They just ended up continuing that onto another line. So please don't try to make it into 4 lists. Same thing with these bottom ones. So just be really careful with that. Okay, I'd like to review what this computer printout is telling us. So the first thing they tell us is dependent variable is FYGPA. That is our Y variable. Sometimes they give you stuff that you don't need, like this no selector thing that's not necessary. The next thing they give us is the R squared. And you guys have seen R squared before. We actually usually write it as a lowercase r. It would be 0.754. R squared adjusted we aren't going to use, so you can ignore that. The next thing that they tell us is S equals 0.2118. This is the standard error of the residuals. They also tell us in that same line that there are 14 degrees of freedom. And you'll notice that they did count the number of data points, which is 16, subtracted 2. So that's where that comes from. So then looking below, usually you're going to see this listed as constant or sometimes intercept. That is the other way that it's going to be written. That's going to tell us that this negative 1.56 is the slope of our line. So that's is the y-intercept of our line. So that's the first important thing down there. The next thing that they give us is they give us another variable, this HSGPA, high school GPA. That is our x variable. And then the coefficient of the x variable, remember, is the slope of our line. So then the other thing that's necessary, this t ratio is not important. So we are working with, if you look at the hypotheses on the previous page, it's looking at slopes. Actually, this probability right here, it says prob, this is going to be our p-value. And make sure you choose the one with the slope, because our test is going to be on the slope of the line. So please try not to choose the wrong one. The other probability we're not going to worry about right now. Okay, so for part A, I actually would like you to pause the video and do this on your own. I think you can probably do it by now, so pause. Okay, so if you did that, you are going to end up getting y hat is equal to 1.30527 times x minus 1.5640. Now, I actually would say if you do this, you must define your x variable. Now, there's another way to do this, and I actually prefer the other way. I think it looks nicer. The other way that you can write it is you can write this as first year GPA with a hat on it is equal to 1.30527 times high school GPA minus our y-intercept there. So this is my preferred way of writing it, but if you do the first way, that's fine as long as you define the x and the y variables. This is another problem where I recommend that you pause and you try it on your own because I think you might remember it. Now, if you don't remember it, I will go over it. So this one, they want you to find the residual. This tells you there's a point on the graph. I actually don't know what happened to that graph, but you don't really need it. So what we're going to look at is we're going to look at how to calculate a residual. And this is a bit of review. So a residual is equal to our actual y value minus our predicted y value. You might remember RAP. So our actual y value, if you remember y is our first year GPA, this is going to be our actual. Our predicted y is not so easy to find. This is going to be our x. So you actually have to do some work here. And we do work by using our equation. It's not going to be that bad as long as you know what to do. You're just going to take the 3.8 and plug it into that equation up there. So when you do that, you do end up getting 3.396. And so my residual is equal to 3 minus 3.396, which is going to give me negative 0.396. So that's my residual. You'll notice I do have a negative residual. That's fine. That means I'm lower than what I expected. So I'm hoping you noticed that everything we've done thus far has been review. Now we're going to do some of the new stuff. And so the part C, we're looking for evidence of an association between high school and first year GPA. So when we're looking for evidence of an association between two quantitative variables, that is a sign that we are going to use a linear regression t-test. So my null hypothesis is going to be beta 1 equals 0. My alternative hypothesis is going to be beta 1 is not equal 0. You can, as I said previously, you can either write the parameter or you can just write it in words. So I'm going to say there is no association between high school GPA and first year GPA. And then the alternative is that there is an association. So we now have our hypotheses done. We do have to check conditions. And on this one, I actually realized now that they gave us a picture of the scatter plot, but on mine it got cut off. So if it got cut off on yours, I'm just going to tell you right now that the scatter plot was evenly scattered, the residual plot was evenly scattered. So I apologize if yours got cut off. So the first condition is that the scatter plot and residuals have no bends or changes in spread. You might notice here I'm putting 2 into 1. That's fine if you do that as long as you mention both of those. And the residuals are nearly normal. So the final thing is the random sample, and that actually is also satisfied. Okay, so we've done our hypotheses, we've done our conditions, we've named our test. For the mechanics part of this, actually, you don't really have to do anything because they gave it to you already. They told us that the p-value is less than or equal to 0.0001. That's a very small p-value. So for conclusion, then we can just write it out based on that. And the conclusion hopefully will seem very familiar. Because of the small p-value, we reject the null hypothesis. There's evidence of an association between high school GPA and first-year GPA. So let's do the final question together. We're going to create and interpret a 95% confidence interval for the slope of the population of regression line. We've actually already checked all conditions. We've defined our variables. So now we're just going to go ahead and go straight into our interval. Our formula is B1 plus or minus T star times the standard error. So let's do this one together. B1, they gave us up there, it was the slope of our line, which was 1.30527. So then for T star, you are going to have to look at the table. Remember, our degrees of freedom was 14. You do end up getting 2.145 when you do that. And then the last thing that we're going to look at, this is where it gets a little bit weird. The standard error is going to be the standard error of the slope. And I think I didn't actually label that. So you're going to want to probably go back up and label it because it's important. And that is going to be the 0.1993. So then you do have everything available. The only thing you're going to really have to do any work on is the t-table part. Then you're going to go ahead and do the interval. You end up getting 0.88 to 1.73. You might notice that 0 is not in this interval, which is good. That matches our conclusion. So don't forget the interpret part. If you forget that, you will lose points. And you're always going to interpret these in kind of the same way. You're going to mention your confidence level. You are going to mention the parameter, which is the true slope. And you're also going to mention the context, first year GPA and high school GPA. I'd recommend actually on a big test that you write it out. And then you're going to mention that it's between these two values.